Hello boys and girls, welcome to Math with Mr. B. Today we are going to be comparing volumes, so you should have your journals open up to page 13 right now. So if you're not there, go ahead and take a second to get there. Now, number 1 says, create cylinders A and B from half sheets of paper. What could you measure about these cylinders? Well, I don't know any half sheets of paper that are going to hold water, so I used a couple of plastic receptacles. This is a graduated cylinder, and this is just a little cup. And the shorter one is A, and the taller one, the tall skinny one, is B. You can see that or not? There, B. All right, so you know what? You're just going to have to remember that. A, B, A, B, A, B. So the question is, what could you measure about these cylinders? So when it asks you that, it means how could you try to measure these? If you took a ruler, what dimensions could you measure? Go ahead and take a minute to brainstorm some ideas for that and record those on number 1 on page 13 in your journal. Teachers, this would be a good time to pause the video. All right, fabulous. Now, number 2 says, which cylinder do you think has a greater volume? Explain your answer. So right now, cylinder A or cylinder B, go ahead and make a prediction, a hypothesis, which one you think has a greater volume, and we're going to test that out by taking the oxidane in this container and actually, you know what? We're not going to do that. We're going to put oxidane in this container Oh, no, that is what we're going to do. Okay, so we're going to test that theory out by pouring the water from here into here. Oh yeah, oxidane is just a fancy word for water. So here's our graduated cylinder, and that is cylinder B. By now, hopefully you've made a prediction of what you think is going to happen. We're going to test that. And if you look what happened, this cylinder here filled this right around halfway up. Now many of you might be a little bit surprised because this one is so much taller than this one. However, the volume, or how much space it takes up, is much less. In fact, I'm curious, what if we fill this up again? What would happen? So I'll fill my graduated cylinder B up again and go ahead and just make another prediction. Do you think we can fit a second one in here? Let's find out. Look at that, ladies and gentlemen. Cylinder A has twice the volume of cylinder B. Now looking at that, that may surprise you. However, the reason why is because if you look at this, the difference in the diameters of each of these, you'll find the diameter of cylinder A is much larger than the diameter of cylinder B. And what is diameter, you may ask? Well, diameter is the distance, if you were to measure from one edge of the cup to the other edge. One edge to the other edge. And as a result, the cylinder A has a much greater volume, or 2 times the volume, of cylinder B. So if you look at number 4, that should help you answer those questions where it asks, how are the cylinders different and how are the cylinders the same? So what they're asking for, they use the word attributes, and all attributes means are characteristics, or the different things you can measure in both of these cylinders. So you look at the height, the diameter, the height, the width. So if you look how the cylinders are different or the same, well, you can say they're both round, they both can hold water. The ways they're different would be the height and the diameter, or the width. Those would all be different. So I hope this helps start you off to an understanding of comparing volume. Your homework tonight, you're going to have the opportunity to compare the volumes of different household containers. So you can do an experiment similar to this one at your own home tonight. Please be careful whenever working with Oxidane, as it does make things wet. Good luck.